What? I'm not going to shoot water at birds. I did not say that.
That would be bad.
I did not say that.
Bad idea.
Yeah.
Okay, so here's kind of a slight different version of that first equation. The only difference is this doesn't have the a in front of it. It's the exact same equation, but it gives you a different value. So what this gives you is the fraction.
What?
What that gives you is the fraction of collisions that are above the activation energy. So if you look at this mathematically, T is going to be your temperature. So what this, if you go through the math, the higher this temperature is, the higher that frequency factor becomes. Right? This frequency, this number fraction of collisions, it's always going to be less than 1. If you do this and you get like 5, you have done something horribly wrong, because it's the fraction of collisions that are above a certain point. The whole point of this that I want you to see, and I hate Wednesdays, is that if you raise this temperature, you get more collisions above that. Now, here's the last one, and then I'm done. Then I'll turn you loose. And this is one that certainly I will give you on the test. Whew. So what this does is that it allows you to compare different K values based upon temperature. This is a really fancy way of finding, like using the slope of a line. So what you're going to have is a certain temperature and a certain value of K. And then if you run it at a certain other temperature, you can predict and calculate what the other K value would be. So all this does, this just comes from that graph of where you have the natural log of K and 1 over temperature in Kelvin. And these are just X and Y coordinates. So all this does is if it tells you, hey, at this temperature, this is what this K value is. If we run it at a different temperature, what should the new K value be? That's all that does. Okay, I hate Wednesdays. I apologize for rushing through this. Normally, I have more time. So here's your assignment.
Guys, good prank, don't worry. Oh, it's April. Oh, April Fool's. Oh, April Fool's.
No. Yes, you're going to have to draw some graphs. Now, this will make sense when you get to 50. Okay? When you get to number 50, this will make sense. Do 39 and 80 only. That will make sense once you get to number 50. And also pay attention to when you get to C, that C is assuming a zero order reaction. When you get to 50C, it's assuming a zero order reaction. It makes sense when you get there.
Why 61A?
Huh?
61A is underlined?
61A and B. I'm sorry. I meant to unlink both of those. I gotta make sure that's not on the same page. Hold on.
So what are you going to do? Charge it? I'm wearing a belt, so.
Technically, 50 starts on page 614.
50 is the one with 39 and 80.
Yeah, it'll make sense when you get there. Technically, that starts on page 614. Number 50 is technically on page 614. They gonna do?